Hello and welcome. In this video, we're going to review linear models. And our goal today, or our objective, is that I can write the equation of a line including parallel and perpendicular lines. So let's go ahead and jump right in. Now you've been learning about lines probably as long as you can remember in math. So what I'm going to encourage you to do is to just pause the video and list anything you remember about lines. That could be pictures, it could be bullet points, it could be things that we referenced in previous videos, but go ahead and just list anything that you remember off the top of your head about lines. So hopefully you've had some time to work through that. Here are some things that I think about when I think about lines. The very first thing I think about is slope, and we know that that's y2 minus y1 over x2 minus x1. The next thing I usually think about is slope-intercept form, which is y equals mx plus b. I also think about point-slope form, which is the form that we're going to be using pretty heavily. That's y minus y1 equals m times the quantity x minus x1. I think about horizontal lines, which are along the horizon and have a slope of 0, versus vertical lines, which go up and down and have a slope that's undefined. And I might also remember something about parallel lines, which has this symbol that's like two lines right next to each other, versus perpendicular lines, which has the symbol an upside down capital T. And some of this might be a little bit rusty, but for the most part, this is content and topics that we have been working with for a really long time. So let's freshen up on those skills, first focusing on identifying the slope given a function, given 2 points, given a variety of different things. So let's practice with finding the slope. If we're given an equation that's in point-slope form, the slope is just that number that's in front of the quantity connected to x. So in this case, slope is 6, because 6 is in that spot for point-slope form, right? This is y minus y1 equals m times x minus x1. So the slope in this case would be 6. If we're given a line that only has one variable, such as y equals -5, we need to figure out if that's a horizontal or a vertical line. So y equals -5 means that y is constant, which means we have a horizontal line, and we already talked about the slope of a line like that being equal to 0. Now, if we're given information in a different way, such as in a form that's not point-slope form or slope-intercept form, we may have to either transition the equation into slope-intercept form, or we could find the intercepts, plug in 0 for x, plug in 0 for y, and then with 2 points, we can find the slope using the slope formula. So let's put 2 more examples up here for us to practice finding the slope. So I'm going to encourage you now to pause the video, find the slope for the equation of the line on the left, find the slope for the line passing through the 2 points on the right, and then unpause the video and see how you did. So as I mentioned, for the one that's in, and this is actually called standard form, the first thing you could do is rewrite it in slope-intercept form, so solve for y, and then you can identify the slope as the m in front of your x, which is 2/3. The second thing that you can do to review a previous section is you could actually find the intercept. So to find the x-intercept, I can plug in 0 for y. So this goes away. 2 times what is 6? 3. So there's my x-intercept. Then I can find my y-intercept by plugging in 0 for 2. -3y equals 6, so y is -2. And then we can use that slope formula. For number 2, we're just going to jump right into using that slope formula, or if you really wanted to, you could plot the points and count the rise over the run. I'm going to go ahead and use the slope formula. When we do that, be careful with the double negative situation. Make sure you remember that when you subtract a negative, it becomes addition. And simplify, you're going to get that this slope is 1/8. So now that we've reviewed finding slope, we can tie that into our newer review concept of writing the equation of a line. What we're going to focus on in this class is that when you write the equation of a line, go ahead and write it in point-slope form. In older classes or in previous courses, you learn about writing equations of lines in slope-intercept form because that really makes it easier for you to graph if you can identify the y-intercept. But in this class, we're really just focusing on having the equation of a line. Transitioning it into slope-intercept form is just putting you at risk for making a basic math mistake when all we're really looking for is just the equation of a line, and point-slope form is the easiest way to go about doing that. So let's look at an example. So let's write the equation of the line with points 1, 2 and negative 1, 4. So go ahead and pause the video first and find the slope, and then unpause the video and see how you did. Hopefully you had enough time to do that. If not, pause the video again and make sure you do. Our slope here is going to be negative 1. Now, if we're going to use point slope form, all we need to write the equation of a line is the slope and any point. So I'm going to go ahead and use this point. So we're going to write y minus the y value of this point, which is 2, equals our slope, negative 1, times x minus the x value of this point. Yes, you could also use the other line, which would give you this equation. I try to avoid this if possible because this negative 1 means I have to change this sign here. These are both the exact same line. You could see this to be true if you put it into slope-intercept form. But again, either of these answers would be an acceptable line for passing through these 2 points. Okay, let's look at another example. All right, here we are given a point. Even though this notation looks a little confusing, this is a point. This is just the point 0, 5 and a slope. So go ahead and pause the video and write the equation of this line, and then unpause the video and see how you did. And here we have the equation of that line. Now it does seem a little silly to have x minus 0. You could simplify this to be y minus 5 equals 3x. And some of you will want to put it into slope-intercept form, which would be y equals 3x plus 5. But again, this is an acceptable final answer. Let's add one more layer of challenge before we move on. Here we go. Now don't let the notation confuse you. You're given 2 points here. So find the slope and write the equation of the line, and you can pick either point when you're writing the equation. Go ahead and pause the video, work through it on your own, and then unpause the video and see how you did. And there we have it. Now that we've reviewed writing equations of lines and finding the slope, let's move into parallel and perpendicular lines. All right, so as a reminder, parallel lines are lines that have the same slope. So they are exactly the same. They both have a slope of 2. They both have a slope of negative 15. Perpendicular lines have 2 things about them that make it significant. They have slopes that are opposite in sign. So one of them is positive and one of them is negative. And they are reciprocals, meaning it's like you flip the fraction. So for example, 5 and negative 1/5 would be perpendicular slopes. A quick way to see that is that if you multiply them together, you should get negative 1. So let's look at this example off to the side over here. It says fill in the slopes for each function in the table below, given that f of x is parallel to g of x. So let's start with just that. If f of x is parallel to g of x, that means when f of x has a slope of 2, so does g of x. When g of x has a slope of negative 1, so does f of x. And perpendicular to k of x, so what would the slope be for k of x if the slope for f of x is 2? What would the slope for f of x be if I changed its sign and reciprocated it? Hopefully you got that that would be negative 1/2. For the next line in our table, if g of x is negative 1, I take the reciprocal of that, I still just get negative 1, and I change the sign, I get positive 1. That's actually one of the trickier ones. A lot of people have trouble reciprocating 1, but the reciprocal of 1 is just 1. All right, I'm going to have you pause the video and see if you can find f of x and g of x's slope if the slope of k of x is negative 3/2. Then unpause the video and see how you did. All right, if I take the reciprocal, I get 2/3 instead of 3/2, and if I change the sign, I get positive 2/3 instead of negative 3/2. So now that we've reviewed how the slope works between parallel and perpendicular lines, let's tie that back to what we just learned about writing the equation of a line. All right, here we go. We're given the line y equals 2x minus 4, and we're being asked to write the equation of the line that's parallel to that point and passes through the point negative 1, 3/5 for part A, and perpendicular to that point for part B. So go ahead and pause the video and write those 2 equations. Remember, leave it in point slope form, and then unpause the video and see how you did. So hopefully you had time to work through that. Pause the video, check over your answers, make sure your slopes are correct, and then let's move on to reviewing graphing lines. So just as a reminder, when we're graphing lines, we can always graph the y-intercept and use the slope to move our rise over our run. So for this first one on the left, I'm going to start at the point 0, 5. I'm going to move down 3 and right 1 to make my next point, and I'm going to keep graphing points like that until I run out of space, and then I'm going to connect the dots with arrows on the ends. And there we have that line. I'm going to encourage you to pause the video and do the same thing for the second graphing problem. And there we have our quick review on graphing lines. Let's go ahead and wrap up this video. All right, so this section was about linear models. Our goal was that we could write the equation of a line, including writing equations of parallel and perpendicular lines, and we threw in a little brief bonus on graphing. So go ahead and write down any questions you have, and I look forward to supporting you on this. Thanks for listening.